Here is an expertly drawn Entonox cylinder. You know it's an Entonox cylinder because it's blue and white. It contains Entonox, which is a 50-50 mixture of nitrous oxide and oxygen. These two are mixed together and they are in a gaseous form in the cylinder. Unlike a nitrous oxide cylinder, which is totally blue and has liquid and vapour in it. Because it's all a gas, like oxygen, we can measure what's inside with a pressure gauge, and when full, at room temperature, the pressure is around 13,700 kilopascals, or 137 atmospheres of pressure, which is the same as an oxygen cylinder. Entonox is a strange gas, because it's a strange mixture of oxygen and nitrous, and the way it's manufactured is using the pointing effect, which is where you essentially bubble one gas through the other, you end up dissolving them within each other, and the gas mixture ends up behaving differently to how you'd expect the individual gases to behave. But you just need to be able to say the pointing effect for the exam. The major risk with Entonox is these two separating out in the cylinder, and this will potentially happen via the process of lamination if the cylinder is allowed to get below the pseudocritical temperature of Entonox, which is minus 5.5 degrees Celsius. So cylinders must be stored above this temperature. If it does separate out, what you can end up with is liquid nitrous forming at the bottom and then pure oxygen on top. If you then give this to a patient, they'll start taking the oxygen and they won't have any nitrous, so it won't give them any pain relief. And as the oxygen disappears, the nitrous will then evaporate to replace it, and you'll end up giving a dangerously hypoxic mixture of nitrous. So to prevent that, you can invert the cylinder a few times before you give it to the patient to make sure it's all mixed up. You can make sure it is not stored below its pseudocritical temperature, and you can use a dip tube, which is a bit like a straw in a plastic drinks bottle, which ensures that the gas is taken from the bottom of the cylinder first, which means even if there is some degree of lamination and there's more nitrous liquid at the bottom, if that is allowed to evaporate up the dip tube, this nitrous still has a little bit of oxygen dissolved in it, so it ends up being about 20% oxygen. If you take this off first, you'll get lots of nitrous, 80% or so, but you'll still give 20% oxygen, so it won't be dangerously hypoxic as you remove the nitrous from the bottom. So the mixture you'll be giving will be getting weaker and weaker from a nitrous point of view, but it will never be dangerously hypoxic. So a dip tube is an important safety feature as well. That's everything you need to know about Entonox for the FRCA exam.